Hello everybody and welcome to Mrs. Baker's Monster paper. This is module 5, it's the paper 4 edition. And I've kept the 3 magic triangles up here so that you can follow along. Remember, you need to be able to remember these for the exam because we will be working between them. So question 1. The equation for the decomposition of hydrogen peroxide is shown, and here is the equation. It tells you that 25 centimeters cubed of aqueous hydrogen peroxide forms 48.0 centimeters cubed of oxygen at RTP, and then it's asking you to calculate the concentration of aqueous hydrogen peroxide at the start of the experiment. You can just dive straight in with your table method exactly as you have done in your guided notes, okay? So the first thing that you need to say is, well, it's asking me to calculate the concentration of this, and it's giving me the volume of this. It's also giving me the volume of the hydrogen peroxide. So as oxygen is a gas, then we can remember that, but also you can see here that oxygen is a gas, right? So you know that you're in this vol-mol 24 triangle. You also know that it's given you the volume of an aqueous solution, so you know you must be in this mol conc vol here. So we know we need mol, conc, and vol in our table, and we also need the volume. We also need the volume of a gas and 24. Now, obviously, you don't have to put 24 in your table. I like to put 24 in my table because it's something that I then don't have to remember, and I just write it in straight away like that. I know that I'm on 2 hydrogen peroxides, H2O2, and I know that I've got O2, so I've actually got a 2-to-1 ratio here. Now I can plug in what the question has told me. Well, the question has told me I've got 48 centimeters cubed. Remember, centimeters cubed must always be turned to decimeters cubed. So I've got 48 over 1,000 here. It's also told me I've got 25 centimeters cubed of hydrogen peroxide. So this is my aqueous volume. So I've got 25 over 1,000. So now what I can do is I've got 2 in this column, so I can calculate the third. I've got my vol and my 24, so I just need to do 48 divided by 1,000 to get into decimeters cubed. Then I can divide by 24 because that's what my triangle tells me to do. So I end up with 0.002 moles of that. Well, if I've got 0.02 moles of that, I've got twice as much of that, so I need to times by 2, 0.004. And now I've got my moles and my volume here of my aqueous solution. So I've got my moles and my volume here. So I've got my number of moles on my calculator already, 0.004. I'm going to divide that by 0.025 because that's what 25 over 1,000 is. Divide by 0.025. That gives me 0.16. So my concentration is 0.16 moles per decimeters cubed. So now I can come to my question, calculate the number of moles of oxygen formed. Well, I just pull that off the table. That's here, 0.002. Deduce the number of moles of hydrogen peroxide. Well, that's here, that's 0.004. And calculate the concentration. Well, that's easy, that's 0.16. See, your table method has just worked it out beautifully. Now, oxygen can also be produced by the decomposition of potassium chlorate, which gives you the formula for. The only products for this decomposition are potassium chloride and oxygen, so they're the only products, write a chemical equation for this decomposition? Well, we just put in what we know. KClO3 makes only potassium chloride and oxygen. How do we know that it's potassium chloride is KCl? Because K forms a +1 ion, it's in group 1. Chloride forms a -1 ion, it's in group 7, so it's just a 1-to-1 ratio in the formula. How do we know that oxygen is O2? Well, remember, have no fear of ice cold beer. Oxygen is diatomic. Now all we need to do is balance it. So we've got 2 oxygens and 3 oxygens. The lowest common multiple of 2 and 3 is 6. So I just get those into 6. And now I've got 2 potassiums, so I need 2 potassiums over here. I've also got 2 chlorides. I've got 2 chlorides over here. My equation is balanced. And that's question 1.